Welcome back to the channel. To accurately navigate and operate a ship efficiently, mariners need to know the true wind, not just the wind they feel. The wind you feel on a moving vessel is the apparent wind, and calculating the true wind from this is a fundamental navigational skill. Remember, the apparent wind is the wind measured by the ship's instruments, resulting from the combination of the actual atmospheric wind, the true wind, and the wind created by the ship's own motion. This combination is a classic vector addition problem. To find the true wind, we must perform the reverse operation, vector subtraction. Think of it this way. The apparent wind vector is the sum of the true wind vector plus the ship's velocity vector, which is treated as a wind coming from the direction of the ship's movement, known as the boat speed wind. Therefore, the true wind vector is found by subtracting the ship's velocity vector from the apparent wind vector. The essential data points we need for this calculation are the ship's true course and speed, its velocity, and the measured apparent wind speed and direction relative to the ship's bow. Traditionally, this calculation was done graphically using a maneuvering board or a dedicated wind triangle diagram. The ship's velocity vector is drawn first, representing the ship's course and speed. From the tip of this vector, the apparent wind vector is drawn, representing the observed speed and direction. The vector that closes the triangle, connecting the starting point of the ship's velocity vector to the tip of the apparent wind vector, is the true wind vector. Its length represents the true wind speed, and its direction points to the true wind direction. For example, if your ship is heading north at 10 knots, and you measure an apparent wind of 15 knots from directly ahead, the true wind must be 5 knots from the north, 15 knots apparent wind minus 10 knots from your motion. However, if the apparent wind is 15 knots from the northwest while you sail north at 10 knots, the calculation becomes more complex, requiring the vector diagram to solve for both the true wind speed and direction. Modern vessels automate this process, with sophisticated sensors and integrated navigation software performing the vector subtraction in real time, instantly displaying the true wind data. Knowing the true wind is vital for several reasons. It ensures the ship is not overstressed by unexpected weather, allows for optimal routing to minimize fuel consumption by avoiding or harnessing wind and waves, and is essential for accurate weather forecasting and reporting. Always rely on the true wind for strategic decisions. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.